Hi students, this is the last component of your Sec 4 chemistry work. Okay, and this component is known as organic chemistry. So this is very important, especially for students who are going to A levels, because organic chem is a big part of your H2 syllabus. Okay, so what is organic chem? This is the study of carbon-containing compounds, except the CO, CO2, and carbonate. Okay, so carbon-containing compounds, we will learn about the structure, properties, and the reactions. Okay, most of the time, we call them hydrocarbons. Okay, so hydrocarbons are compounds that contain carbon and hydrogen only. So why do we study this? Is because organic is like living. Okay, so in our body, it's actually made up of about carbon and hydrogen atoms. Okay, so it is a big part of all these living components that we are studying. Okay, so naming organic compounds, we have what we call the homologous series. So what is a homologous series? This is a family of molecules, family of organic molecules that has a general formula. Okay, and it will differ from members of the same family by a CH2 group. So an example will be this, right? This carbon-containing compound is the simplest. Okay, remember your carbon in your periodic table is 6 and 12. This means that 6 electrons, the electronic configuration is 2,4. Okay, so carbon and hydrogen, non-matter, they form covalent bonding. So hydrogen is 1, 1. So the electronic configuration is 1. Okay, so your carbon need 4 electrons to become noble gas configuration. When it need 4, it share 4. Okay, when it need 4, it share 4, it left 0. And your hydrogen needs 1 to become noble gas configuration. Need 1 will share 1, and because one of the electrons is being shared, it will form 0. So in other words, what does this mean, right? It means your carbon can form 4 bonds. They form bonds to achieve noble gas configuration. Okay, hydrogen can form 1 bond. So if you convert your 4 bonds and 1 bond to a simple CH compound, your hydrogen compound, hydrocarbon compound, you will have this structure. Each of it is a covalent bond. Cross belongs to carbon, dot belongs to hydrogen. And they are in the noble gas configuration. Okay, so this one is the first member of a homologous series called alkane. The next member will differ by a CH2 group. So the next member will have 2 carbons. Okay, and likewise, each carbon will have 4 lines coming out, and each of it will be bonded to a hydrogen. Okay, so if we look at this second member, this CH3 is exactly the same. This H is here. Right, what did the molecules differ by? It differ by a CH2 group. Okay, so they are in the same series because they are all carbon, carbon, single bond. Okay, and the homologous series is called alkane. Okay, because they have the same general formula and they have what we call the same functional group. Okay, functional group, what does it mean? It means this combination of atoms which give these molecules a chemical property, a specific type of chemical property. So in this example, the functional group is your carbon-carbon single bond. All the carbon is bonded singly by a single covalent bond. Okay, so because they have a unique functional group, this will arise to similar chemical properties. Okay, because of the same functional group. Okay, and there's a gradual change in the physical properties due to increase in size and mass. Later we will look at what are these physical properties. Okay, so these are your characteristics of your homologous series. right? So let's look at these common homologous series that we are going to learn. We have the alkane as illustrated over here. A and E, these are all carbon-carbon single bond. So if you look at all the carbons, they form single bond. And it will have this formula CN H2N plus 2. So look at this. There's only one carbon, so C1 H2 1 plus 2. You get your CH4. This one, there's two carbons, so C2 H2 2 plus 2. So 2 times 2 is 4 plus 2 is 6. You get C2 H6. So there's 6 carbon, there's 6 hydrogen, 2, 3, 4, 5, 6. Okay, so this is your alkane, the first homologous series. Then we have the alkene. Alkene, what is the functional group? Carbon-carbon double bond. Okay, so instead of a single bond, we have a carbon-carbon double bond. And we will have this formula CnH2n. So as an illustration, we will have alkene, which will look like this. Okay, the first member of your alkene. 4 lines coming out of your carbon, 1 line, 2 line, 3 line, and 4 line. 1 line, 2 line, 3 line, and 4 line. 4 covalent bonds. Okay, each of the line is bonded to a hydrogen. You have this formula C2H4, right? Where your C2, your N is 2N. You have this formula. Okay, next homologous series, we have the alcohol. Alcohol, the name of your functional group is called hydroxyl. And what is this hydroxyl? It's this OH. So oxygen, in your periodic table, the electronic configuration is 2, 6. So 6, it needs 2 electrons, share 2 electrons, left 4 electrons. So what does this mean? It means my oxygen can form 2 bonds to achieve noble gas configuration. Okay, so we have your hydroxyl group, the OH group. Okay, so you can see my oxygen now, there's 2 lines coming out from it. Right, and it has this general formula Cn H2n plus 1 OH. So the first member will look like this. The rest of your carbon bonded to a H. Okay, following this, we will have the formula C1 H21 plus 1 OH. So CH3 OH. So CH3 and OH. Okay, and then we have the next one, which is your carboxylic acid. The functional group, what does it look like? It's your C double bond O, single bond OH. Usually when we represent it in a condensed formula, we will write it like that. Okay, and we have Cn minus 1, H2n minus 1, COOH. So your carboxylic acid will be, example, your ethanoic acid. Oxygen got 2 lines, each oxygen got 2 lines, hydrogen got 1 line, carbon got 1 line, 2 line, 3 line, 4 lines. This part fill it up. Okay, so following this formula, Cn H2n, Cn minus 1, H2n minus 1, COOH, you have C2 minus 1, H2, 2 minus 1, COOH. And if you simplify it out, it will be C, H, 2 times 2 is 4, minus 1, CH3, COOH, CH3, COOH. Okay? And last but not least, we have your ester group, which is an ester linkage. C double bond O, single bond O. So this single bond oxygen is bonded to R. R can be any atoms, any non-metals, except H. Because if it is bonded to H, it will be a carboxylic acid. Okay, and same idea, this is your general formula.